This video is a summary and brief explanation of SACE Stage 1 Chemistry Unit 1.3, Mass of Particles. If you cannot understand, please watch the other, longer, more comprehensive video. The mass of a proton and a neutron are so small that we measure it in atomic mass units. One proton and one neutron is one atomic mass unit. It doesn't connect to conventional mass measurement at all because these particles are so small. To solve this, we invented a unit called the mole, which is the number of particles needed to make the mass of a sample in grams the same as the number of atomic mass units in the substance. So, 1 mole of protons is 1 gram, and 1 mole of neutrons is also 1 gram. Why is this? Because 1 proton and 1 neutron is 1 atomic mass unit, because that is the definition of atomic mass units. The approximate number of particles in a mole is 6.022 multiplied by 10 to the 23rd power. This is known as Avogadro's number. This number is so weird because atoms are not sentient and don't conform to our concept of grams. In order to make atomic mass units and grams per mole the same number, we had to compromise with our constant. You may look at a periodic table and see that its mass number is not a whole number, but how can that be if we're only measuring protons and neutrons? Well, each atom has a relative atomic mass, which is the average mass of every isotope that that atom has in the universe. For example, almost all of the carbon in the universe is carbon-12, 6 protons and 6 neutrons. There is some carbon-13 with 7 neutrons and carbon-14 with 8 neutrons, but that is in the minority. As a result, we say that the relative atomic mass of carbon is 12.01, because while most of it is 12, if you have a mole of the substance, you'll expect a couple of carbon-13 and 14 atoms in your sample, which will skew the mass of it up. Each atom has a relative atomic mass. Relative atomic mass can also be called relative molecular mass, based on how the particles are bonded. Moles count the number of particles, not atoms. If it is individual atoms, there is approximately 602 sextillion atoms. But for example, in a mole of water, there is no longer 602 sextillion atoms, but 602 sextillion water molecules, 2 times the number of hydrogen atoms, and overall 3 times the number of atoms in a mole. However, this is still considered a mole. This means the relative molecular mass is actually the sum of all of the relative atomic masses inside the molecule. Back to H2O, there are 2 hydrogens and 1 oxygen. 2 hydrogens, 1.008 plus 1.008 plus oxygen, which is 16. The answer, 18.016, is the relative molecular mass and the number of grams in a mole of water.